do need to clean off that whiteboard. Jeez. Yeah, dude. Can I see that? I can see that too, man. I should have done this ahead of time. All right. Oof. Why is it? Why do I keep on going out? Cool. All right. Man, my glasses turned darker. Look all cool and trendy.
Wasn't it the right guy?
Right.
It's one of the slots. In the rack.
All right, let me mute you, Scott. All right. So let me finish getting all my stuff set up here. So it is 1 o'clock. It is time for a workshop with Ammon. Today's workshop is going to be a title that I can't remember. What did I say it was going to be? Database Foundations, 0 to CRUD, and I can do it in 30 minutes instead of 40. And I thought that was a hilarious title because, well, I thought it was hilarious. So we're going to be working in SQL Electron. This is going to be for SQL stuff. So that's the first portion of our Database Foundations class is SQL. So that's going to be our focus. I'm going to be solely inside of SQL Electron. And we're going to discover our 4 CRUD operations. If you are not familiar with the CRUD acronym, or this is the first time you have seen it, let me actually pull over a little notepad window and I can type and talk at the same time. Right? So CRUD. CRUD is short for create, read, update, delete. Create, read, update, and delete. The 4 major actions we can do with data. Right? Pretty much in any type of programming or database, if we can do these 4 things to a piece or a set of data, we are in full control. We can create data, read data, update data, and delete data. Right? We're actually going to go in a slightly different order. We're going to do CRUD, read, create, update, and then delete. All right. Where did my SQL Electron go? There's my SQL Electron. So I'm going to connect to my local Chinook SQLite database. And I'm going to make my query window a little bit bigger. And a little bit bigger this way as well. So we can all see what's going on. Right. This is my stock Chinook database. I haven't done anything to it yet, but we will be doing stuff to it shortly. So the first thing, read. Read. It's our first order of business. I need to be able to read data. There's a database. I want to get data out of it. Right, so read. Read is the select query. I can say select star from albums. And if I execute that, that gives me all of the data out of the albums table. Right? I can replace any of my tables over here on the left with this table name here, and it will give me information. It'll give me all of the information out of that table, all of the rows and all of the columns. So that's my read. My read equals select. My read is a select statement. How do I create? Create. Right? A create is going to be generally an insert statement. Ooh, capitalize, insert. Right? Create is an insert statement. All right. And with an insert statement, that allows us to insert data. If I can read data, I can put data back into a table. For example, I'm going to look at the artists table, because that one's pretty small. It only has 2 columns. If I select from artists, I will see that I have an artist ID and a name. And if I want to create an artist, I can do that with an insert statement. So I can say insert. I need to say where I'm going to insert my data. Insert into artists. I need to tell it what columns I want to insert data into. Right? In my database, already pre-configured, the IDs are automatically entered for me. I don't have to worry about them. So the only part I do have to worry about is the artist's name. Forgot to mute my music. We had a soundtrack going the whole time. All right. So insert into artists. I say what columns I want. Right. These are the columns. Columns that I'm going to insert. I'm going to say values. Values. And then I say this is the data that I'm going to insert. So insert this data into these columns into this table. So I can say Ammon. And if I execute this guy, it'll tell me there's been executed successfully, affected rows 1. Right? If I go at the top and I execute my select again, and I can execute specific queries in here by just highlighting them. I can highlight that one right there and press execute. That'll run just my select query. If I scroll all the way to the bottom, I should see Ammon right there. Number 276, right? So it allows me to insert into that table. Right? I could keep on inserting as much data as I want. I could insert my name again if I wanted to. I could insert multiple things at the same time. I would just treat them as different rows of data. A new band, left-handed smoke shifters. Right. Execute. I go down to my artists and select that again. I should see at the very, very bottom the new data I've inserted into here. Right. That was my first time executed. This time I got item 277, 278, and 279. Ammon, Frank, and left-handed smoke shifters. Right. If I wanted to insert into more complicated tables like tracks, it has all the columns listed there. My query just gets horizontally more complicated. I add more columns up here. Maybe it'd be, let's see what that one would look like actually. I'm gonna do another one below here. Insert into tracks. Make it the columns I want. So I'd have name, album ID, media type ID, genre ID, composer, milliseconds, bytes, and unit price. That's a lot of columns, right? And values. Pretty much for each column at the top, I need to put its value in there. I can't skip any and I can't exclude any. If I put it in this list of columns, I need to have a value down at the bottom. Maybe I had a track named Where's My Froggy? On album 1. I'm just going to pick random numbers to see if this works. 1. Media type. That's album ID, media type, then genre. Composer is D, because it's the D composer. Milliseconds, 9,000. Bytes, 9,000. Unit price, 3 easy payments of $99.99. And I should be able to run this guy and insert it. Get this column up here without any problem. Execute. Successfully executed. If I then want to look at my tracks, I can say select star from tracks. I can just go ahead and read my data, write a quick query to execute and prove that what I just did worked. It's going to take a second to execute because I believe tracks is the biggest table in here. And at like 3579, 3504. That was close. But if I scroll all the way to the bottom, yeah, it's going to take a minute. 23, 25, 26, 27, 30, 3, 4, 5. There we go. Where's my froggy? There's my track that I made. All right. So if I try to be fun and get rid of one of these columns and then try to execute this guy, I'm going to say, hey, can't do that. You're missing one. You don't have the same number of things. Where did that go? I think I inserted something weird into my query. There we go. 8 values for 7 columns. So if I put name back, and if I get rid of one of these values, do the opposite, it's going to say 7 values for 8 columns, right? The number of columns and the number of values needs to match up in every scenario. Otherwise, it won't work, right? So just make sure that for all your column names and your values, you've inserted them all. So that covers read and create, right? Read is a select statement, all the fun things I can do with a select statement. And create is an insert statement, insert into. You insert into columns and you put values into those columns. Our next thing is U, update. Update. Update is typically an update query. Right? An update query is pretty straightforward. Say, for instance, I added an artist earlier. I had an artist named Frank. What if I wanted to change Frank's name? What if I spelled it wrong? What if I called him Frank instead? What if Frank was his name and I put Frank in there? So to update this, I do update. And I give the name of the table. Update artists. I tell it what to change. I say set name equals Frank. Where name equals Frank. So I tell it to update this table, set this value with this criteria. It's going to go row by row and check this criteria. If that criteria matches, it's going to run my update. Execute this guy, it should execute successfully. Set the name Frank to where the name was Frank. So if I do select star from artists, I execute select star from artists just to prove to myself what I did. I'm going to scroll all the way down until I see what used to be artist formerly named Frank is now Frank. I've updated that one specific row. If there are more properties and I wanted to update them, I can just separate them by commas. Say for tracks, if I needed to update like the unit price and the milliseconds at the same time, I could do that. So an update statement is fun. They are dangerously fun because, well, there's no going back. If your where clause is too generic or too broad, you can potentially update a whole lot of data first, right? So a good thing to do, since an update has a where clause on it, is to run that in a select statement first and see what you get. That will show you the data that you would be updating. So if I did select star from artists, where name equals Frank. This should tell me, and this should give me the exact data that I would be updating. Right now there's nothing, because I already fixed it. What if I misspelled his name twice and I wanted to make sure to update this guy? It'll give me the one row back. That proves to me that that will only update one. And if I've proven this query will only pull back one result, then my update will only update one result. Or if I wanted to be doubly safe, I would use the artist ID I would get back. Where artist ID equals 278, because that is the unique identifier for the artist. Using an ID is a much more secure way to update only a single item instead of all of the items. Okay. All right, so we did read with select, Create is insert. Update is update. Last one, delete. Delete is, of course, the delete keyword. Right? What do? We say what we want to delete. Delete from artists, where name equals Ammon. This should delete any of the artists in that table with the name Ammon. It should delete 2. Affected rows 2. Right? I had inserted 2 Ammons and I deleted them. If I run this again and execute it, it will tell me it didn't do anything. It executed successfully and that's it. There's no additional data to be deleted because I just deleted it. Right? So delete from artists where name equals Ammon. Again, just like a select statement, just like our update, a delete is pretty easy to accidentally delete the wrong things. And it's just as easy to, instead of the delete, 2 dash, say select star. That will ensure that I'm going to be looking at the data that I will be deleting. And if I swap my select for my delete, then I will delete only that one item. Cool. So viewing the data that you would be deleting is a great way to make sure you're not going to accidentally be deleting anything. Right? So read is select, create is insert, update is update, and delete is delete. Right? Those are our SQL keywords to do all of our basic CRUD operations. They can get vastly more complicated, but this is the simple subset of 4 operations. These are the primary ones we're going to be dealing with data, especially when we tie into other front-end or back-end systems that are going to be executing some semblance of these queries behind the scenes. And this is the work that they will be doing. Right? So if a user enters data into a form, it's going to end up as some sort of an insert statement. If they modify it, it's going to be some sort of an update statement. If you're displaying just data on a page, it's going to be some sort of a select statement. Same with deleting. If something's marked to be deleted, it's probably going to look like some sort of delete statement. All right, so that's our 4 basic CRUD operations: create, read, update, and delete. Right? So then that brings us to not just CRUD operations with data, but maybe some CRUD operations with tables. Maybe we'll do that one next time. I'm going to double check the curriculum. So I think that stuff is middle of next week. I want to make sure everybody's equipped for, I believe, just lesson 1, 2, and 3. Double check that real quick. That would be crazy. Database. Well, I should have looked at this ahead of time. I was planning on it, but got a little bit away from me. All right. 5. Let me start. 11:05. Yeah. Got my database class. All right. So then, final parts of the 14th. So yeah, so lesson 2 and 4 hands-on for this week. Lesson 2 is joins. Lesson 4 is creating tables. So I am on target for creating tables. Awesome. Didn't want to throw too much out there to begin with. So 4 basic data operations: create, read, update, delete. Right? I can also create and remove tables. I'm going to create a table inside of my Chinook database here. I'm going to create a table. I'm going to say create table. I'm going to give it a name. Create table potatoes. Fruits. Create table fruits. Fruits. And I do open, close parentheses and a semicolon at the end. I give it columns. Like say my fruits have an ID. And my ID is going to be a int. I'm going to say integer. Comma at the end, then I'm going to put a column called name, which is a, I'm going to do string. Text. Name is text. Kind of use my autofill to help me out here. Create table fruits. Column ID, column called name. Execute this guy. It should execute successfully. And hey, I have fruits. With an ID an integer and a name is text. So using what I already know about my CRUD operations, I'm going to try to add data to my newly created fruits table. I'm going to insert into fruits. I'm going to do the ID and the name because I haven't set up any type of automation with the ID yet. Values. Fruit number 1 is banana. Fruit number 2 is grape. Is grape a fruit? I think grape's a fruit. It has seeds on the inside. There's fruit seeds on the outside. I can remember. Number 3 is a strawberry. So I want to insert these 3 fruits into my table. I can execute this. It'll tell me I've affected 3 rows. So I want to select from there to make sure it worked. Select star from fruits. If I execute my select statement, it should give me my 3 fruits. 1 banana, 2 grape, 3 strawberry. Bam, right there. So I create a table with a couple of columns. I insert some data into it, and I select data from it to make sure that works. What if I made a mistake in my table? Right? What if this was supposed to be fruit ID instead of just ID? Right? I can't recreate my table. If I run my create again, it's going to give me an error message. Table fruits already exists. So instead of creating a table, I can drop a table. Dropping a table removes the table by that name. So when I say drop table fruits and execute that, my fruits table goes away. And now I'm allowed to recreate my fruit table and I can make my change. Fruit ID, camel case.
When do you set up your integer string?
Which one?
Well, I see your integer, and I know you have to set up a string at some point, correct?
I did it for the name. I just have an ID and a name.
I see.
Number and a name.
So for the integer string, it would be, don't you set that like depending on what someone is allowed to input on the next one? Meaning you have so many characters you can put in for that integer, correct?
So for integer, it'll just take any number, and text will take any string.
I see. So when you're setting up your database, do you have to set those values as far as your integer string?
No. In SQLite, I don't have to.
You don't? Oh, okay.
I can make them generic if I want to.
I see.
Right? But I could drill this down more specifically and be like, this is going to be a var char 10.
Okay.
Right? I could get as specific as I wanted to.
Mm-hmm.
I can keep it extremely generic and say just, this is going to take some sort of text.
I see.
Right? Since I'm not really concerned about any size constraints or anything, at this point, it's quicker just to, because I can always change it later.
So with that value, would that be, what would give the next input? What would the value be? In other words, how many characters could they put in with you not putting a value in there?
Text, I think, is pretty big.
It's like 40, isn't it?
I think default text is, I don't think it has a limit.
I see. Okay. I didn't mean to take you off your
That's okay. Yeah, no, it's text is pretty much just whatever you put in there. It'll take, you probably put like a couple chapters plain.
I see. Okay.
I drop table fruits. I want to recreate it. Right? I think I ran that already. So I'm going to notice that my fruits table doesn't look any different though. SQLite needs a kick in the pants sometimes. So as soon as I refresh it, it kicks in my new values, fruit ID and name. But now if I want to insert data into here, it's going to tell me to change my column name. So now I need fruit ID. And now I can insert my data in. Right?
Yes.
Those three. And now it has, if I select from there, it gives me my fruit ID and then my name. Right?
Mm-hmm.
If I don't want to have to worry about the IDs, maybe I just want to add fruits in here. Right? I'm going to get rid of my fruit ID column up here. And I'm going to change this fruit ID. This is going to be a primary key. So it's going to be a unique identifier. It's going to be primary key. I need it. Integer primary key auto increment.
Okay, so it will actually sum up an amount, correct?
Yep. So if I run this, if I drop my table and recreate my table and insert my data back in and then select it back, I should have ID 1, 2, and 3 again without adding them in.
Mm-hmm.
If I run my insert again, I'll get my fruits again, and I'll have ID 4, 5, and 6. Right? So integer primary key auto increment pretty much tells it to every time I insert an item into this table, assign it a number and increment it for the next one. So it'll always keep on increasing that number. So then I don't have to worry about IDs anymore. I can just insert the data that I want.
Correct. Interesting.
Which is pretty neat. Takes away a lot of the legwork. That way I don't have to remember what the last, I don't have to worry about what the last ID was, what the last number was. I just insert my data in, and then I can select my data back out to double check and verify it.
Mm-hmm.
Yeah. In a nutshell, that's our CRUD operations. There's 4 for working with data. There's only drop and create for tables inside of SQLite. There's not a alter table method available to us, but it's pretty quick to just drop and recreate a table if we need to. And then reinsert and select our data back out to make sure it works. If I keep on executing this like crazy, my ID will always increase.
Mm-hmm.
On adding up as many times as I want, which is pretty neat. Cool. That's my workshop for today.
Well, I appreciate that. Okay.
Yeah, short and sweet, kind of keep it, just focus on our CRUD operations, right? Kind of a good primer to jumpstart some of the LMS curriculum. Groovy. All right, yeah, I wanted to have 40 minutes, but I got to ditch out a little early. What's up?
No, what I had is I'm dealing with, I forgot, I think it's lesson 2. I think I'm on lesson 2 and 4. And some of the queries as they get in is a little difficult for me to kind of understand. But I guess they've given me a mentor, so I will be, I guess, communicating with the mentor on a regular during the week. Okay.
Yep.
And then you will be doing the workshops, and then you and I will be talking towards the end of the week.
Yeah. And your mentor as well. I think your mentor is doing, they're pretty much the first tier because they're going to be doing a one-on-one meeting with you, I believe, to go over some assignments.
Yeah.
And then, yeah, pretty much any question you could possibly have, they should be fully equipped to answer for you.
They've been really helpful, and for the most part, I've been over this before, so that's been pretty helpful too. So,
yep.
Okay, very cool. All right, thank you.
All right.
All right.
Have a good evening.